do an example here for you on problem 57. This is on page 307, but I have the problem here for you to look at. So they give you this function, they have a capital H here, h of x equals the integral from 0 to x f of t dt. And they tell you that f is a continuous function with the domain from 0 to 12 graphed here. So this is the function of f of x. This is not h of x. So I want you to kind of be able to interpret what this graph is and how it relates to all these questions. So if we were to find h prime of x, then we would be taking the derivative of this integral. And notice the setup for the fundamental theorem of calculus, because the limits match both with x's. We have a constant here. We're taking the derivative of an integral. So then that means that h prime of x is equal to f of x using the fundamental theorem of calculus. So that means this graph right here that we're looking at, we can consider as h prime of x. So, they call this f of x, but we want to think of this as the derivative. So this is a derivative graph. That's going to be important when you think about the relationship going on with this problem. So part A asks us to find h of 0. So now I'm going to go back to what h is. So I want to find h of 0. So I plug in a 0 where the x is on my integral. So my integral is from 0 to 0, f of t dt. Remember that when the limits of integration match, we get 0. So whatever these had been, if they match, we get 0. That was one of our rules for integration. Part B asks, on what interval is h increasing? So think about this. Remember, h is increasing think about when we did a lot of these where we said, how do you know when f of x is increasing? Well, f of x is increasing when f prime of x is positive. So using that same relationship, h is increasing when h prime is positive. That's the relationship between a function and its derivative. So we need to know, when is h prime positive? So we look at our graph and we can see that it's positive. H prime is positive when it's above the x-axis. So that's on the interval from 0 to 6, because we can see that's where my graph h prime of x is positive. And that's it. That's the answer. Part C asks, on what interval is the graph of h concave up? Well, h is concave up. Remember, for concavity, we look at second derivative when h double prime is positive. Okay, well, we don't have the graph of h double prime. We don't know the function. We only have the graph of h prime. Well, think about the relationship between those. H double prime is positive when h prime is increasing. Okay, think about this, what we said just a minute ago. H is increasing when h prime is positive. In general, a function is increasing when its derivative is positive. So h prime is increasing when its derivative, which is h double prime, is positive. It's exactly the same relationship between h prime and h double prime as we have between, say, any generic function f of x and f prime of x. So we need to know where h prime is increasing. So when we look at our graph and we look at when is this increasing, well, you can see from 0 to about 9, it looks like it's decreasing. So it appears to be increasing on the interval from 9 to 12. So we could have from 9 to 12. Remember, when we talk about concavity, we usually don't include the endpoints, so I'm going to leave those off and just say from 9 to 12. Okay, so next, on part D, we have, is h of 12 positive or negative? So we need to think about that now. So let's look at our picture. So h of 12, so if we plug that back into our integral, so that would be from 0 to 12 f of t dt. So this is h of 12. Okay, so it's going to be positive. Remember what that means we're looking at. If we're this is h prime. So h, if we want to talk about what h represents, is the area under the curve. So h of x represents the area under the curve. Well, remember that this is positive. The area, the accumulated area, is going to result in something positive if we integrate this. And here, this is going to be negative. Well, I know overall it's going to be positive, and my reason would be the area above, let's see, let me think how I want to word that. Okay, so I would word it maybe this way. The area between the curve and the x-axis on the interval from 0 to 6 is greater than from 6 to 12. So you can kind of tell from visually looking at it that it appears to be greater, which means we have, remember, if you integrated, if we knew the function and we integrated, it would go from 0 to 6, treating that as a positive, and then from 6 to 12, this would be as a negative, so it's going to actually look at the difference between those, and so we would end up with a positive result. All right, the next question, part E, says, where does h achieve its maximum value? Okay, keeping in mind that, think of this as the integral as accumulating the area under the curve. So think about at 2, the area under the curve would be, like if we approximated even with a rectangle. At 4, you can see there's a larger positive area. At 6, there's a larger positive area. Well, then remember what happens when we dip below the x-axis. Then if we're evaluating an integral, we would be subtracting this area to get this net change in our integral. So at x equals 6, that's where the accumulated positive area will be the greatest. So that's going to be where h achieves its maximum value. Okay, for the last question, where does h achieve its minimum value? That's going to have to occur when x equals 0. Because if you, when x equals 0, plug in a 0 for h of 0, remember we already did this, from 0 to 0, which means that integral equals 0. So we know that h of 0 equals 0. We also know that h of x is increasing on 0 to 6. That was where it was accumulating the positive area, so it's increasing. We also know that h of 12 is positive because there was more positive area than there was more area above the curve than below the curve, so we know that that result is going to be a positive answer, which means that h of 0 must be the minimum. So that minimum value is going to occur when x equals 0. All right, so you as a group in your groups are going to be doing problems 58 and 59, but I wanted to just kind of give you a little heads up. So this time we're talking about a position function. S is the integral from 0 to t f of x dx. They tell you that s is in meters, t is in seconds. So then if you find s prime of t, which we know the derivative of position is velocity, you take this derivative, d dt, of this integral, which means we're going to use the fundamental theorem of calculus, which gives us f of t. So v of t is f of t. Now they used an f of x here, they probably should have used an f of t, but the point is this graph is v of t. So the graph that we're looking at is the velocity. So since the graph that we're looking at is the velocity, then s of t is represented by the area under the curve, so that's the accumulated, that's the distance traveled. So we can see it's accumulating a positive distance, and then it's switching directions and going back the way it came. So that's that idea here. And then I may have just given you some answers along there. And then acceleration, which equals the derivative of the velocity, is represented by the slope of the tangent line as we move along the curve. So that means looking at the slope of this graph, the slope of the tangent lines along this graph, looks like it's fairly linear right here. So we have a linear slope. So when you look at that, that represents the acceleration. So this is typical on the AP exam where they give you a graph of velocity and they ask you questions about position and acceleration, because questions about position relate to the integral and the area under the curve, and questions about acceleration relate to the slope of the line, the derivative. So they kind of get both big ideas from calculus from one problem. Problem 59 is kind of set up the exact same way. So if you follow through, it's the same value. It's the same thing for s from 0 to t, f of x dx. So when you look at, so it's the same thing where we have, this is the velocity. So it's very similar setup. So when you go through and talk about that, you can see that. So that should help you on 58 and 59. Do those problems first, and then you have your other assignment that, but these would be good to have, the whole group working together.